Hello, this is Anthony, and this is a video on the 909, the T909 specifically. And this is going to show the calibration and some setup for the computer, scoreboard, whatever you're trying to do. So if you just have the regular 909, you see it has a 5-pin connector. So these are pretty easy to connect. You just get your 5-pin from your scale, plug it in. If you have the hardwired version, then it's going to be a little more difficult because we'll have holes here where the wire is going to go through. So you're going to have to unscrew everything and actually open it up. So I would have this open up, and you'll see where the 5-pin comes in. This is colored wire, goes to this connector here. So if you have the hardwire version, it wouldn't look like this. You will actually just have one of these connectors on the board. So this will be on here, and you might not realize which one is which, because you have your scale, and your scale will have red, green, white, black, maybe yellow, or this clear cable. And you have these connectors, but which one goes where? So if you actually look close here, you'll see E+, that's the red cable. You see that's the one all the way to the left. And you'll see S+, which is a signal cable, which is this green cable here. HD is a shield, and that's the yellow cable here. S- is the white cable, and that's the one right there. And E- is black, and you see it right there. So this one's pretty easy because you just, this is one connector you put in. It's the way you set up, but for this one, it's going to be labeled in the same order. So for yours, you're going to have to get a mini screwdriver, loosen up, get the same correct order. So the one all the way to the left is E+, which is always red. So you'll get your red connector, put it in there. Let's see, so here, and actually screw it down. So that's the first connection. So this will be on the board itself, on the hardwire version. And then you continue on, red, green, yellow, clear, white, and black. And you'll see on the screen. So next will be the actual calibration. So close it up, here it is. So first, if you have the normal 5-pin connector, then you just connect it here. This is for the load cell, and this is for the plug. And this is what you're going to use for computer or scoreboard, the RS-232 DB9 connection. So first turn it on. And if you have any problems, I'll show you the first thing you do where, let's say, it's not weighing at all or it's giving you U's or enter. Let's first check the C15 setting. So we're actually going to need to get into the menu, hold down the hold and print button for 2 seconds. You see C01. So first, we're going to check C15. So these little arrows will direct you where to go. So this one moves right. So make that tens place flashing. Make that to 1. So now it's C11. Move right again to make the ones place flashing. And you press 0 to go to C15. I skipped over it, so I could go down, pressing enter. That's good, and now I can enter in. And you can see my raw data. So this is what the calibration is based on. If you see all 9s, that means you connected something wrong. The load cell is damaged, or the wire is damaged. If it's some kind of damage or the wiring issue is wrong. So if you put weight on your scale, like I just did, you see the number get larger. Add more weight, it goes up again. And if I remove the weight, it goes down and it goes down. So you'll see that this is responding to weight. This is not pounds, this is just numbers. The indicator calibration, that's what actually tells it. These numbers are this much weight. So if you put weight on it, it should go up. You remove weight, it should go down. If this is correct, then the rest of the calibration is fine. If not, recheck if this cable is damaged. Check the wiring internally if you have a hardwired or on the floor scale, and check for any damages at all. So I have a separate video on how to fix a floor scale, how to fix a bench scale, all those other videos, but this is just for the calibration. So this is all fine. So let's go down. See, you press enter, it's 0.0. I'm going to hold on the hold and print for 2 seconds. You see C01. So this is the calibration. C01, you press print. C12. You might have C11. C11 is for kilograms. I use pounds, so I make go up C12 for pounds. C02. This is the amount of decimal places I will have. Right now it's 1 decimal place. If this is like a floor scale, you have 0 decimal place because 1 pound accurate. If it's a bench scale, you might have 1 decimal place or maybe 2 decimal places depending. So right now, I'll set it to C20 because I want 0 decimal places because this will go in the floor scale. C03, this is how it's counting by. Right now it's counting by 5s, and since I put 0 decimal places previously, it will be 5 pounds. This is by 2, this is by 1, right? This will be 50. So it counts by 50 pounds. If this was 1 decimal previously, then it would be, if this was like 5 like it was before, that means 1 decimal counting by 5s means half a pound accurate. Out of 1/2 pound accurate, this will be, if it was 1 decimal before, this will be 0.2 pound accurate. It's counting by 0.2s. And it will just round. If you have 0.1, then it will just round up or round down. So since I put 0 decimal places previously, this will be 2 pounds. C31, because that is 1 pound accurate. My floor scale is 1 pound accurate, so C31. CO4 set to max capacity, so I can move right. Right now I have the 1,000 place flashing, and I want to make this to 5, because it's a 5,000 pound floor scale. Because 5,000 pounds is the capacity that I'm weighing, so that's good. Let's print. CO5 is a 0 calibration, so press print. C50, press the 0 button to make it to 1. So now make sure there's nothing on the scale. Remove all the weight because it will 0 out the weight on the scale. Now press print. Cal 0. 0 is good because there's no weight on the scale. C06. So now C06, press print. C60, so to get into the menu, you make that to 1. C61, and you press print. You'll see span, and now you see weight for calibration. In my case, I'm going to use 50 pounds, so I'm going to make the 100th place to 0, and make this to 5. Whatever weight you're going to use for calibration, you're going to dial in now. If you have 100 pounds, you want to say 0, 0, 0, 100. If you have 50 pounds like me, you'll say 0, 0, 0, 50. If you have 1,000 pounds, use 0, 0, 1,000. So this recommended to use 10% of the max capacity, and that depends on the scale. On a 5,000 pound scale, you want to use a calibration weight of 500 pounds, which is 10% of the max capacity. If it's a 500 pound bench scale, you want to use 10% of 500, which is 50 pounds. If you have nothing else to use, you can use your body weight and stand on the scale. So if you have 150 pounds, you could say like 150, for example. And you can just stand on it if you know your body weight. I'm just going to use a 50 pound weight for now. So I'm going to add the weight to your scale now. So matches whatever weight I put on my scale. Now press print. Okay, that's good. Number and cal end. Now remove the weight from the scale. Press print. You'll see C06. So now you're at C06. To escape, you see the ESC to save and exit from the menu. Now I'm back at 0. So now when I put my weight on there, you see 50 pounds shows up because that's my correct weight. So that's how you connect it. And if I add another 50 pounds, you'll see 100 pounds. It's 1 pound accurate. So that's how you get the calibrate the T909. And next I'll show you how to connect it to a computer. So this section is for the 909 connected to a scoreboard printer. So if you have regular connection, you'll see a DB9 connection. So you could get a normal DB9 to USB cable to plug into computer. If you have the hardwired version, it'll be the same process. It's just you'll see connections up here, and they'll connect to the 9-pin connector down here. So you see pin 2 is your transmit, and it goes to the first connector up here, and it's hard to see, but it's labeled TX. That's the first connection up here. Then the middle connection here is RX, which is green, that receives. So that connects to pin 3 of the DB9 connection on the board. And then pin 5 is your ground. It's labeled GND, which is your pin 5 on the board here. So make sure the wire goes through and goes to the board. And it will have a similar connection to this, but only have 3 connectors. So make sure you wire it from, this is from right to left. You see red, green, black. Be labeled on the board. Transmit, receive, and ground. And you'll know because when you connect to the computer, you won't get any signal out of it, or you will. So this one, I'm just connecting it to RS32, and I'll show you on my computer. Well, before I plug it in, what's gonna happen. So I'm on my desktop, and you'll see you can right-click on the start button to easily, quickly go to Device Manager. Because when you plug it into a computer, you will see a COM port appear. So right now I don't have any COM ports, but maybe you do. You can click on it and expand it, and you'll see more COM ports. So I already have it here, and when I plug it into a computer, you'll see what happens next. And in a second, you'll see ports, and you'll see COM6 appears. If I unplug it, you'll see it go away. And if you already have other COM ports there, the port section won't disappear, but mine does because there's nothing else plugged in. So you know which COM port is assigned to your 909 now. So that's good, because with the COM port, you can now know how to communicate with the device. So close this, and the manual on this, you go to optimascale.com, and other literature and manuals, you go to OP909, same as the T909. And a lot of the details will be explained in the manual. So the first thing we'll do is, okay, we know the COM port. We want to set it up where this device will send the output to a computer, and then the computer would actually be able to read it. So there's 2 settings. We already did the calibration previously, so we could skip the CO1 to CO6. UHX C15, so communication setting is C18 and C19. C18 and C19 are the only 2 settings that will affect the RS232 signal output to a scoreboard, printer, or any other device. So first you turn on your device, and you'll hold down the hold and print button, and want to go to C18. So hold and print. Right. C18. So now C18 is set to 1. If you look on the screen, you'll see C18.1 is continuous sending mode for remote display. This will be for like a 910 or 910X or hours or any other scoreboard. So let's try it out for now, and you'll see what's going on. C19 is the baud rate. So that's the connection to the software. So we use C19.3 for 9600. So that's fine. And that's it. So I downloaded a software called Putty on desktop. And with this, I could open up the COM port, and this is called a hyperterminal software. And you can use any software you want. It's just a free version that's on the internet to use. So I'm putting serial, COM6, because we checked our device is COM6. The baud rate 9600, which is what we're using. And for here, C18.3, press print. To exit from the menu, press escape. And you now see that it's outputting a continuous sending data. If you don't believe it, let me add weight to scale. And now you see it says that number. It says 50 pounds, but it shows up like 500,000, 5 million, whatever it is. I could add more weight, right? Move the weight back to 0. So this is continuous sending mode for a scoreboard, which is fine if you're using 910, but I'll show you the other ones. So go back into here. C18.2 is for a paper thermal ticket. So that'll be OP412. You'll set. So I'll show you what the output's gonna look like. So C18. Go back, hold down. C18.1, right? Make that to 2. Print C19. That's not going to change. It's going to be the same baud rate. So let me just show what's going to show up on the hyperterminal. And then you press escape. So right now it's 0. I could add weight to the scale. 50. Nothing shows up on the terminal because I need to press print. And then now you see the date of the device, the time, and the gross weight. And if I tared whatever weights on it, it's now in net weighing mode because I tared off 50 pounds. And now I could add more weight, 100 pounds. And when I print, you'll see now it says date, time net weight of 100 pounds. I tear it off 50 pounds and the gross weight was 150. So that will only show up if you tear something. If you didn't tear something, for example, I untear it, back to 150, and now it only shows date, time, and gross. So just so you know, that's how the string output comes out from this device. If you don't see your net and tear, it's because you most likely didn't tear anything. So this is for your printer, your 412 and your 412L2. So that's fine. But let's try another one. Let's try C183. So C183 is for command request. So C183 and escape. So very similar, but see, I could print something and now it shows the weight, but I have to press it. But this is unique because you put it on the keyboard. See, I could put capital R on the keyboard and I actually get the weight. I put capital P on the keyboard and I'll get the print of it. Capital T will tear, and you see all the different commands. If you actually scroll down in the manual, somewhere down here, C183, you see capital T will tear it, capital Z will zero it out, capital P will print, capital R would read the gross weight or net weight, capital C would change from kilograms to pounds, and capital G would give the gross weight. So if you write any software, as for example our data logging software, will take the string output and will send the data from the computer to the device and will tear it from the software. You get the weight, you can print from the software, you can do a lot of different things from the data logging software. If you write your own software, that's fine. You just need to have your program open the COM port, send the command, whatever command on the screen here, and it will output whatever you request from it. That's called a command request. It's a two-way communication. So if you want to run your software that way, that's fine. You just put C183 and the software will do everything else from there. So if you want, and this is not continuous, the only way continuous is if you write software that does it. You notice on the terminal, it doesn't actually show up anything unless I press a button or press a button on the keyboard. So if you want to continuously send it, and for a lot of people that's fine, go C18, C18, set to 4. So now you see it's continuously outputting the weight. I could change the weight, lower the weight down, 200, immediately responds. And you see, that's how it works. Very quick, very easy. Just realize that this is one-way communication, meaning this device is going to output through the RS-32 to USB to program. Whatever COM port software or PuTTY or whatever you're using, it's going to continuously output. If you send a command from the computer to the device, it's not going to do anything. I mean, I could type in capital R, capital T, I could do anything. It's not affecting this device at all. It's not commanding, it's not controlling. On the previous C183, I'm able to send a command to tear, and it will tear out whatever's on the scale. This one doesn't. It will just output one way. Some people that's fine, some people don't want it, it's up to you. So next one will be C185. So you see for PC, remote display, continuous sending mode, very similar. See if I increase the weight, it actually changes, but it's only on one line. It's not continuously output line. So this is very popular for like a scoreboard usually. I'm not seeing people use C185 for computer usage. So if you're connecting it to whatever scoreboard and this is a specific string output it wants it in this format, that's what you can use. It's continuously outputting. If you remember previously, can't even see it, on C181, that's for that specific string output. That's continuous, but that's for a scoreboard like a 910. And you'll see what the exact string output is on down here setting. In your case, maybe you want it, maybe you don't want it. So not too popular setting, so we can set C186. C186. So now it's not doing anything, but if I hold on the print button, now it outputs all this text. Let's do it again. See, now you see the date, the time, the gross, but it has a lot of other characters in front of it. This is for the OP412-L1. So that specific printer, it's a zebra printer. So that one specifically wants all these characters in front of it. This actually is the format for the label. And this is the actual output from the device, the date, time, and gross that's saved on this device. This will output to your zebra printer. That's our L1. There's also C187. It's very similar output. It really depends on the printer you have, what kind of string output they want. It's not a problem with the device. The device is just outputting the string, and it's up to the printer that would actually accept it. And you'll see if I put C187, it's a little bit different, but it still has that date, the time, and the gross. So if you have a zero printer, try either one. And that's kind of it. The C1808 is not really used. So for continuous devices, you typically, for a scoreboard, you use C181 or 5. And for printers, C182 for 412 or 412L2. And then if you have an L1, it's C186. And if you want just command requests where you write software where I send a command to this device and the device communicates back, I could be able to control the scale from my computer. That's C183. And if you just want this device to continuously output weight to your computer, let's say you want to log data, send to Excel, whatever you want to do, send a C18 to 4. That will output continuously, and you'll know if it's working or not. If during the wiring process it's not working, then maybe you flip the transmit and receive by accident, flip those two, reconnect it. If it's just DB9, you don't have to worry about that, but if it's hardwired, maybe you flip it by accident. So make sure you have the proper transmit and receive, because there's only 3 connections, so it's not that many possibilities. And that's kind of it. For C19, you need to set 0 for an OP910, you see in the manual. So that's for the scoreboard. So 910 will be C18-1 and C19-0. So that's kind of all the features, and if you're able to get the output from the PuTTY software, then you know it is working. If you're not getting any output, no matter what software you run, it's not going to work. Because this is just going to open up the COM port and reading the data. If it doesn't read any data, it's not the problem with the software. It's probably because you connected it wrong or using the wrong setting. So I recommend everyone use C18-4 just to see if you get any output at all. And then once you get output from that, then you can start working on the other devices. So then you connect to your printer, scoreboard, whatever you're trying to do. Anyways, and that's how you connect all the 909 to computer, printer, or scoreboard using different settings. All right, thank you.